All right, so we've done geometric series and infinite geometric series. We have our rule here. And basically, we're just trying to find out if r is less than 1. If it is, it converges to this. And if r is greater than or equal to 1, it diverges. And in the video before, it explains why that is true. So we're just looking for that proper fraction, like that 5/6. So we know that's going to converge. We just have to show what it converges to. And if you remember our exponent rules from before, we have this. And then this is a quick little trick that we'll be using. So if you see r to the n, we can convert it into an n minus 1 by just doing r times r to the n minus 1. So this is r to the 1. And if you use our exponent rule, remember that's just adding them together. So this would be r to the 1 plus n minus 1, and you can see the 1's cancel, giving us r to the n. So if we have 2 to the n, we can say that this is 2 times 2n minus 1. It's a quick way to make this into this. And now you can see that our a is 2, our r is 2, and this would diverge. So let's try one. So we look at this sequence. I've got our Desmos video here as well, Desmos graph, to see that it converges or diverges. And let's see what we can do. So first thing to do is to split it. We want to have that exponent to be all by itself as an n, like that. And so we're just using our multiplication exponent rule. And so now this would become the sum of n equals 1 to infinity of 25 over 36 to the power of n. So we're one step closer now. Now we have our n, but we want it to be an n minus 1. And so that's where this comes into play. And so we just rewrite it. So it's just a quick using of those rules. This is 25 over 36. And then now we would have 25 over 36 n minus 1. Now you can see that that a, whatever number is in front, will go as the numerator. And then the r to the n minus 1, that r is what we have on the denominator. Now, I like using this instead. Since we know it converges, we don't have to put the a on top. We can put the a in front. So we can take the a out of that series, right, that summation, and just put it in front. So this would become 25 over 36 times 1 over 1 minus 25 over 36. Now, this is always going to be a proper fraction. So when you subtract them, it should be fairly straightforward. So this is 25 over 36 times 1 over, and then this will be 36 take away 25. So that's 11 over 36. And then now it's just a quick reciprocal. So 25, 36 times 36 over 11. Cancel, cancel. 25 over 11 is what we should be getting. So again, the step is to get it down to an n so that we can apply this quick little trick to make it that n minus 1. And then we can just say, okay, well, that 25 over 36 is less than 1, which means we know it's going to converge. And then we can plug it into our formula. So it'd be a, which again you can put in front, and then 1 over 1 minus r, and then simplify. But now what you want to do is check it. So we pull up our calculator and you hit math and you scroll up and you'll see summation there. And we're going to enter it in exactly how it looks. So you can use x though, 1. But with infinity, we don't really have it. So 1,000 is usually good enough. That's pretty far out there. And then we have 5. Oops, we need parentheses around that. Parenthesis 5 divided by 6, parenthesis, exponent 2n, and then enter. And it gives us this. So now we just test it, 25 divided by 11. And you can see exact answer. So plug this series in to your calculator, put 1,000 on it. If that's not enough, put some more on there. If that's too much, put a little bit less, your choice. But always check your answer to make sure it's correct. All right. And then you can also check it in Desmos. So if I hit play, you can see it actually converging to that number, and it hit it pretty quick. Now it's just more decimals after that as it goes off towards infinity. But yeah. All right, so let's try another one. So same thing, now we actually have two bases with n's, and we want to put them together as one n. You can see one of them is a negative. So if we rewrite this again, this would be the sum of n equals 1 to infinity, and we'll go 4 squared to the power of n. and then 5 to the negative n. Now we know that 5 to the negative n is just going to go to the bottom. So we get sum n equals 1 to infinity. And so 4 squared is 16. And then 5 has a negative 1 on it, so it goes to the bottom, and we would put a power of n to it. So this is really 16 to the n, and then 5 on the bottom with an n. So you can see now that our r is greater than 1. It's actually greater than or equal to, but it's really greater than 1. And so this means this diverges. So all we have to do is really get into that form, because even if you say, oh, I want to rewrite it, you would get 16/5 times 16/5. Let me rewrite that part. 16/5 to the n minus 1. It's still the same thing. That base is not changing on us. So again, if it's greater than 1, diverges. All right, let's try now the most complicated. Oh, wait. We've got to check it. So you see if I hit play, it's just going off. Off to infinity there. So it's diverging. All right, so let's try one more. So same thing now, I'm just adding more exponents. So if we rewrite this, it's the sum, n equals 1 to infinity, and then we go to cubed to the power of n. And then now we've got to use that little separation. So if we know they're subtracted, that means they were multiplied to each other. This is 7 to the 1 times 7 to the negative 2n. And then we rewrite that again. So n equals 1. I'm going to actually change that to an 8 to the n now, times 7. And then see, this is just now on the bottom, and it's 7 squared. But I like to write 7 squared, and we put negative n, because see, that would still be negative 2n. All right, so this is the sum from n equals 1 to infinity. And we have a 7 I'm going to put in front, times 8 to the n. And then now we have 49 to the negative n. So we have 8n, 7, and 49 to the negative n. So this goes to the bottom, and that stays there. So we end up with, I like to take the constant out, 7, n minus 1. Actually, let's leave it in, and then we can pull it out after. And we get 7. And then that means numerator, denominator. So far, so good. Now we just need to make it into an n minus 1. So 8 over 49, and then 8 over 49, n minus 1. Now we can apply everything. So it's 7 times 8, that would be 56. So 56 over 49 times 1 over 1 minus 8 over 49. So here, 8 over 49 is less than 1, which means it's going to converge. And our r here is 8 over 49. So this would be 56 over 49 times, and then again, it's just going to be 49 take away 8. So 1 over, and then that would be 41 over 49. And we flip it. So you can see it's that same pattern. Once you do one, you've done them all. And there we go. Now, all we have to do is check this in our calculator. So this is what I was talking about. I had 1,000 and the calculator says, ouch, I can't do that. So we changed it to 100, and you can see, there we go, which means it hit pretty quick. Yeah, so you can see right around the 15th term here. Let's try that again. Actually, it's right on the 11th. This one just said I'm done. That's where I'm going. I'm sticking with that. So you can see it pretty much got to our approximation pretty quick. And the exact value of our limit was right there. So 56 over 41. There you go.